Imagine walking past a massive warehouse filled with thousands of servers humming relentlessly, lights blinking, fans spinning, and cables stretching for miles. It's not just a technological marvel, it's a gigantic electricity guzzler. These are AI data centers, the unseen engines of artificial intelligence. They power your favorite apps, your smart devices, cloud platforms, and even AI-driven business tools. But there's a hidden story. AI data centers are straining local power grids, causing electricity spikes, rising utility costs, and in some areas, even blackouts. The more AI becomes integrated into daily life, the more power grids are under pressure. While these facilities drive innovation, they also pose a massive energy challenge. Could your AI apps be indirectly stressing your city's power grid? AI data centers consume massive amounts of electricity. Artificial intelligence is everywhere, from streaming services to smart homes, self-driving cars to AI-powered business analytics. We rely on it daily. But powering AI requires extreme computational resources, and that comes with enormous energy demands. AI data centers are specialized facilities designed to host thousands, sometimes millions of servers. They operate continuously, consuming electricity at levels that can rival small towns. Their energy footprint affects not only the environment, but also local electricity infrastructure, utility costs, and the reliability of power grids. In this video, we'll explore how AI data centers are draining local power grids, the reasons behind their massive electricity consumption, the effects on communities and utilities, and what solutions are being developed to mitigate the impact. By the end, you'll see how the convenience of AI comes with a hidden and powerful energy cost. AI convenience comes at a hidden cost to local grids. 1. The rise of AI data centers. Over the past decade, AI adoption has skyrocketed. From cloud-based AI applications to advanced machine learning models, the demand for processing power has exploded. Companies like Amazon, Google, and Microsoft have built enormous data centers to meet this demand. These facilities host servers dedicated to running AI models, storing data, and delivering AI-powered services to millions of users. Unlike traditional servers, AI servers are far more energy-intensive because AI computations involve billions of operations per second. The power demand is continuous, 24 hours a day, 7 days a week. How much energy does it take to power a single AI data center? AI data centers operate like small cities. 2. AI training, the energy-intensive phase. The first major energy drain in AI comes from training models. Large AI models, particularly deep learning and neural networks, require extensive computation to process massive data sets. Training can take days or even weeks, involving constant power draw from thousands of servers. Studies show that training a single advanced AI model can consume as much electricity as hundreds of homes in a year. Add to this the cooling systems necessary to maintain safe operating temperatures, and the energy footprint grows exponentially. Could training a single AI model consume as much electricity as hundreds of homes? AI model training is extremely energy intensive. 3. AI inference continuous energy consumption. Once AI models are trained, they move into inference, the phase where they interact with users. Every query to an AI chatbot, every recommendation on Netflix, every AI-generated image or video involves server computations. Each interaction consumes electricity, and with millions of daily interactions worldwide, the cumulative energy demand is staggering. Even seemingly small AI interactions, like a voice assistant answering a question, contribute to grid load when scaled across millions of devices. Does using AI just once a day increase grid load? Every AI interaction consumes electricity. 4. Cooling systems, hidden energy consumers. One of the most overlooked sources of energy consumption in AI data centers is cooling. Servers generate enormous amounts of heat during operation. To prevent overheating, data centers deploy air conditioning, liquid cooling, and ventilation systems, which themselves consume large amounts of electricity. In some facilities, cooling systems account for nearly half of total electricity usage. Without effective cooling, servers would fail, disrupting services and risking data loss. Could cooling consume as much energy as the servers themselves? AI data center cooling systems are major electricity users. 5. The impact on local power grids. AI data centers are so energy intensive that they can strain local power grids, especially in areas with limited capacity. Utilities must upgrade infrastructure, add transformers, and sometimes build new substations to accommodate the sudden demand. In some regions, data centers have been linked to power outages and voltage fluctuations, affecting local businesses and residents. The convenience of AI comes at the cost of energy reliability in communities hosting these facilities. Could your neighborhood experience blackouts because of AI data centers? AI data centers place stress on local power grids. 6. Peak demand and energy pricing. Data centers often consume electricity during peak hours, which increases the strain on the grid and drives up energy prices. Utility companies must purchase additional electricity at higher rates to meet demand. This higher operational cost is indirectly passed to consumers, meaning your electricity bill can rise partly due to AI data centers. Even if you aren't using AI directly, you are affected. Could AI data centers be indirectly inflating your electricity bill? Peak demand from AI increases energy prices. 7. Renewable energy and green initiatives. Many AI companies are investing in renewable energy to power data centers, from solar farms to wind energy. While this reduces carbon emissions, renewable energy alone does not eliminate grid strain. Large-scale AI data centers still demand consistent, high-volume electricity that the grid must supply. Additionally, energy storage and battery systems are costly and not always sufficient to fully offset peak demand periods. The challenge is balancing sustainability with reliability. Can renewable energy fully power AI data centers? Green energy helps but doesn't remove grid strain. 8. Geographic concentration of AI data centers. AI data centers are often concentrated in certain regions with favorable conditions, like cool climates or tax incentive. While this makes operations efficient, it concentrates grid load, putting local electricity infrastructure under enormous pressure. In some areas, local communities protest data center expansions, citing environmental impact, rising energy prices, and risks to grid stability. The convenience of AI services globally is being powered by highly localized energy stress. Are certain cities disproportionately affected by AI electricity demand? Geographic concentration amplifies grid strain. 9. Hidden energy costs of redundancy and reliability. AI data centers are not only massive consumers of electricity, they are also built for redundancy and reliability. To ensure services never go down, companies duplicate systems across multiple locations, maintain backup power supplies, and deploy failover mechanisms. Each redundant system requires power, often idling until needed, which adds another layer of continuous electricity demand. Even if one server is not actively processing AI requests, it still consumes power for maintenance, network connectivity, and cooling. This always-on design is essential for seamless AI performance, but it further increases the burden on local power grids, especially in regions where multiple data centers are concentrated. Could backup systems in AI data centers double electricity usage? Redundancy ensures reliability but consumes extra power. 10. Seasonal and environmental impacts on AI energy use. Seasonal changes and local climate conditions also influence how much electricity AI data centers consume. In hot summers or cold winters, cooling and heating requirements can spike, forcing even higher electricity consumption to maintain optimal server performance. Environmental factors such as humidity and airflow in server rooms also dictate energy need. A data center located in a humid region may require more cooling than one in a naturally cool climate. These environmental variables create fluctuations in grid demand, sometimes causing temporary stress during peak periods. Can heat waves or cold snaps increase AI's energy impact? Environmental factors affect electricity consumption. 11. The long-term implications for utilities. As AI adoption continues to grow, local utilities face long-term planning challenges. They must invest in more substations, transformers, and transmission lines to handle the increased load. These infrastructure upgrades are costly and are typically funded by all ratepayers, meaning every household indirectly contributes to supporting AI data centers. This creates a feedback loop. Higher AI energy consumption leads to greater utility expenses, which then get reflected in consumer bills. The convenience of AI is therefore tied not just to technology costs, but also to community-wide energy costs. Will your electricity bill rise because of AI data center growth? Utilities must adapt to AI energy demand. 12. Energy-efficient AI, the future. To combat energy strain, companies are developing energy-efficient AI models. Techniques include model compression, specialized AI chips, and optimization algorithms that reduce unnecessary computations. While these advances help, The rapid growth of AI demand often outweighs efficiency gains. The net effect is still a growing burden on power grids worldwide, making it essential for utilities, companies, and consumers to plan for a more sustainable energy future. Can AI ever be fully energy efficient? Efficiency improvements are critical, but not enough AI data centers are the silent engines powering our modern digital lives, from streaming services to AI assistants. But their energy appetite comes at a cost, straining local power grids, raising electricity prices, and sometimes causing blackouts. Understanding the hidden energy footprint of AI is crucial for businesses, utilities, and consumers alike. Renewable energy, energy-efficient AI, and smarter grid management can mitigate some of the impact, but awareness is the first step. The next time you ask an AI to generate an image, answer a question, or recommend a video, remember, each request is part of a vast, energy-hungry network quietly shaping our electricity grids and costs. Responsible AI usage and sustainable infrastructure planning are essential as we embrace this technology-driven future. AI convenience comes at a hidden cost to local grids. Are you ready for the energy impact of AI?